Hello students, the topic is virtual circuits networks. In virtual circuit networks, we discuss two things, that is the frame relay and ATM. So ATM stands for the asynchronous transfer mode. So before the frame relay, we were using the X.25, which was successful for some period of time, but there were some drawbacks of the X.25 network, that were that it was having the low data rates and acknowledgement was also necessary for its transmission. So with the passage of time, the need for the frame relay arose. So frame relay is a virtual network, wide area network that was designed in response to the demands for a new type of the wide area network in the major communication networks. So network provides commonly implement frame relay for voice VOFR, that is the virtual communication we can say, and data as an encapsulation technique. So what is the encapsulation? Encapsulation means that when we want to hide some information, because we are having different types of the users, some are the naive users, some are the sophisticated users. So we just want to show the data that is required by the user or that is beneficial to the user. So in that case, we make use of the encapsulation technique, or we hide some techniques between the local area network over a wide area network. So this is a quick review about the X.25 network. As we have already told you that it was a very expensive flow and the error control at both end. So, and it was also having the low data rate. So that is why the need for the frame network arises. Then you can see that this is the frame network, the PDU diagram. Here you can see that here is a wide area network connected with a router. The router is connected with the local area network, and this wide area network is connected to the another router, and now this router is connected to the rest of the internet, right? So this is the network diagram of the frame relay. Frame relay operates only on the at the physical and data link layers. So frame relay, the limitation is that it only operates on the two layers, that are the physical layers and the data link layer. Other than that, it will not work on the other layers. So VCIs in frame relay are called DLCIs. So what are these terms? Don't get confused with it. VCIs mean virtual circuit identifiers and DLCIs means the data link circuit identifiers, right? These are the circuit identifiers. They will help in identify the circuit or route for the data to be sent. So they will send us where the data is to be sent, right? These are the identifiers. Frame relay layers. On the data link, simplified core functions of data link layer, and in the physical they are working on the NC standards, right? So the standards defined by the NC, right? So here you can see that the frame relay frame is here. We are having the DLCIs and CR. So what is CR? That is the command response. EA, what is EA? Here you can see that is extended response. DLCI, we have already told you, that is the data link communication identifier. And FECN, forward error explicit congestion notification, backward explicit congestion notification. DE is the discard eligibility, and EA is the extended address. So this is all the frame. So here you can see that the actual data is having the flag, address, information, FCS of frequency check sequence or flags. So it is a very complex frame of the frame relay, right? So the PDO of the frame relay is also a frame, and for the ATM asynchronous transfer mode, that is a cell. So here you can see that the frame relay does not provide flow or error control. They must be provided by the upper layer protocols, right? So it itself not provide the flow or error controls, but it is provided by the data link layer, right? So this is again about some simplification of the address formats or the frame we just discussed above. So there is another term, that is FRADs. FRAD, what is FRAD mean? To handle the frame arriving from other protocols, frame relay uses a device. So FRAD is a device that is called the frame relay assembler or deassembler. It stands for frame relay assembler or deassembler, right? So here you can see that X.25 ATM and triple P are assembled here, right? And then they are passed to the frame relay, and then passed to the thread and then they are deassembled over here. So this is how thread is working. So what we may face the problems in the network traffic, that sometimes we may have the variety of the frames, the size may not be fixed, so these are the problems. So it must be difficult to identify the start or beginning of the frames, so it will also create the difficulty to engage with the traffic, right? So then we needed ATM at this time, asynchronous transfer mode. Is the cell relay PDO is cell protocol designed by the ATM forum and adopted by the ITU-T, right? So the combination of ATM and Sonnet so will allow high speed interconnection. So ATM was not working alone itself, right? So the Sonnet was combined with it. What is Sonnet? Sonnet is a synchronous optical network. Synchronous means the fixed, right? Fixed network. So the size may be fixed, the memory may be fixed, the bandwidth or strength may be fixed, right? So the combination of ATM and Sonnet will allow high speed interconnection of all the world's networks. In fact, ATM can be thought as the highway of the information superhighway, right? So ATM cannot itself work alone to give you the high speed interconnection. The Sonnet must be used in combination with it. A cell network uses the cell as the basic unit of data exchange. So cell is as the PDU of the ATM protocol data unit. A cell is defined as a small fixed size block of information, right? So the size is fixed, right? And it is very small. Here you can see that how multiplexing can be done using the cells. Here we are having the different cells and here pass through the multiplexer, and uh, the multiplexing is done through the cells. So this is how ATM multiplexing is done. Here you are having some the empty slots as we earlier discussed when we were talking about the multiplexing and addressing. So we will just keep them empty, right? So the rest we will do the multiplexing on the rest of the nodes or the frames, we can say, or the smaller ones. So what is the architecture of an ATM network? Here you can see that you're having some endpoints, user to network, network to network, and some switches, some endpoints, right? So this is, you can see that, and two interfaces here you can see, that is the user to network interface and network to network interface. So here you can see that this is the user, and if it is connected to the switch, this is user to network interface. And if the two switches or devices are connected with each other, the connection is network to network interface, right? So this is the difference between both. The next is transmission path, virtual paths, and virtual circuits. So this is the virtual circuits which will be passed through the virtual paths, and this is the transmission path, right? So on the transmission path we are having some virtual paths, and the virtual paths are comprising of some virtual circuits, right? So the next is example of the virtual paths or the virtual circuits. Here you can see that some virtual circuits are connected to the switches are connected with each other. So the path between them is the virtual path, right? The next is that a virtual connection is defined by a pair of numbers, that is the VPI or VCI, virtual path identifiers or the virtual circuit identifiers, right? So when a virtual connection is made, it must be comprising of some virtual circuits and virtual paths. So in order to identify them, we need to make use of the pair of the numbers, that is the virtual path identifiers or the virtual circuit identifiers. So the next you can see here an ATM switch table like routing table for virtual path or virtual circuit identifier. So these are some numbers which are used to identify the virtual circuits or the virtual paths, both the ingoing and outgoing, right? The next, an ATM switch table like routing table for virtual paths, right? So this is the table for the virtual paths only. Here you can see we are having the virtual path identifier is equal to 1 to 1, and on the other side we are having the virtual path identifier 65, right? So where the virtual path VPI 65 is present in the table, that is outgoing, and the VPI 1 to 1, that is incoming. Here we are having it, right? So this is a very simple just overview of the path, so don't get confused with it. This is the virtual connection identifiers in UNIs and NNIs. UNIs are the user network interfaces and NNIs are the network interfaces. So this is how virtual connection is made in between the UNIs. You can see the path identifier size is 8 bits and the virtual circuit identifier size is 16 bits and the total size is 24 bits in case of the user to network interfaces. In case of the network to network interfaces, the size of the virtual path identifier is 12 bits and for the virtual circuit identifier is 16 bits and the total size is 28 bits, right? So these are the virtual connection identifiers in UNIs and NNIs. So this is the ATM cell. Here we are having a header and the payload, that is the actual data. The header is of the 5 bytes and the payload is of the 48 bytes. The total size is 53 bytes. In the header we are having some virtual path identifier and the virtual circuit identifiers. So this was all about the X.25 network, the frame relay ATM. We also discussed their functions, structures and their PDUs, their network diagrams. So this was all about these networks.